So number 1, add up the number of valence electrons. 1 for hydrogen, but there's 2 hydrogens, plus 6 for oxygen makes 8 electrons, which equals 4 lines. Write down each atom, H, O, H, connect them by a single bond, and then add in the number of lines remaining, making sure that each atom has 4 lines around it. Oxygen has 4. As you can see, each hydrogen needs and can only have 1 line, since it can only have a max of 2 electrons. All the other atoms are after an octet. 8 electrons, 4 lines. Right, on to number 2, H3O, which we would add up as 3, 1 electron for each hydrogen, 3 hydrogens, plus 6 electrons for the oxygen, and then the positive charge would mean we'd have to subtract 1 electron for a total of 8 electrons, 4 lines. Again, mark down each atom, H, connect by a single bond, and fill in, we've got 3 lines, and now fill in the 4th line. Now, best to put charged particles in square brackets and write the charge outside the bracket. Represent the charge. Right, on to the next one. F2, fairly simple. 2 atoms, each one with 7. That's 14 electrons, 7 lines. Connect each F and fill in the remaining unshared electrons for a total of 7 lines. 1, 2, 3, 1 in the middle, 3 on the other side, 7 lines. These are called unshared or non-bonded pair. On to the next one, O2, 6 electrons per oxygen for a total of 12 electrons, 6 lines. Bond the 2 oxygens, fill in with the remaining electrons, so I've used 1 line, 2, 3, 4, 5, 6. This presents a problem, since this oxygen has not enough lines, or not enough electrons representing the lines. Therefore, we need to remove one of the valence electrons on the oxygen on the left, doesn't matter which one we choose, and put it into the middle, resulting in oxygen with 2 lines in the middle, and oxygen with 2. It really doesn't matter where we put these valence electrons on the outside. Your sense of symmetry probably would prefer that we would put them in the same spots, but it doesn't matter. On to ozone. We've got 3 atoms, each with 6. That's 18 electrons, 9 lines. So we'll connect each oxygen by a single bond and start to fill in with the valence electrons. We've used 2 lines, 3, 4, 5, 6, 7, 8, stick a 9th in somewhere, and we'll find out that this oxygen has 4 lines. However, the oxygen over here on the right hand side does not. That means we'd like to place this electron into the middle and end up with oxygen, oxygen, double bonded oxygen, 2 valent, 2 unshared pairs. The oxygen in the middle has a single unshared pair, and of course this oxygen has 3. On to number 6, hypochlorite ion, 7 plus 6 plus this negative charge means to add 1 more electron, giving us a total of 14 electrons, 7 lines. That will be analogous to the F2 that we've already written. Cl, single bonded to oxygen. We've used 1 line, 2, 3, 4, 5, 6, 7. Don't forget to put the whole thing in square brackets and show the negative charge on the outside. Let's continue with number 7. 5 electrons plus 18 for a total of 24 electrons, 12 lines. Put the nitrogen in the middle. Generally the first atom listed will be the central atom in most all structures that we'll build that are fairly simple. And so with the nitrogen in the middle, 3 oxygens surrounding it, doesn't matter where exactly. We put those 3 oxygens, and let's fill in with non-bonded pair, and we would end up with electrons around that oxygen, electrons around the bottom oxygen, and we'll come up short this oxygen not having enough. So, oh, pardon me, I didn't add them all up. 12 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Sorry, the nitrogen doesn't have enough. Let me erase that. The nitrogen doesn't have enough lines around it, so I'm going to move this into the unshared, into the bonding position, resulting in, of course, oxygen, nitrogen, oxygen, double bonded, 2 unshared pair, oxygen, and the oxygen remaining. Let's not forget to put the whole thing in square brackets, representing that it's an ion. Next, let's move on to ammonia. And the nitrogen has 5 plus 3 times 1 for a total of 8 electrons, 4 lines. Put the nitrogen in the middle, hydrogens around it, and finish up with an unshared pair on the nitrogen. Slightly different, of course, for the ammonium ion. We've got 5 plus 4 plus 1, and of course that charge means we have to subtract an electron for a total again of 8 electrons. 8 electrons, 4 lines. That fills in quite simply. Put a nitrogen in the middle, hydrogen on all sides. Voila, let's not forget to put it into square brackets and represent the charge. On to number 10. What is that? The chlorite ion. So we'll add 7 plus 2 times 6. The negative charge means to add in one more electron, resulting in a total of 20 electrons, 10 lines. Chlorine in the middle, oxygen on each side. We've used up 2 lines, so we'll fill in with unshared pairs 3, 4, 5, 6, 7, 8, 9, 10. Let's not forget to put it in square brackets and show our charge. On to the chlorate ion. 7 plus 3 times 6. Again, plus 1 more for a total of 26 electrons, 13 lines, resulting in chlorine in the middle, 3 oxygens around. So we've used 3 lines, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th. Don't forget to put the charge on the outside. And last, the perchlorate ion, 7 plus 4 times 6. Again, not to forget the extra 1 electron, for a total of 32 electrons, 16 lines. This is very repetitive, these particular. You get the idea. Put 4 oxygens around the chlorine. I've used up 4 lines. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And finish with square brackets to represent that it's an ion. That's it. Next video will be page 2.